Hello everyone, I'm Sunny, come from SPSS Algorithms team. It's a great honor for me to attend the China Channel University. Today, I will introduce the survival analysis. This is agenda here. Firstly, I will start with the overview of survival analysis. Then, I will introduce the overview of non-parametric distribution fitting. After that, I will introduce the overview of parametric distribution fitting features and parametric regression modeling. I will introduce 3 demos to introduce 3 algorithms. At last, a user case will be shown in the SX. Survival analysis overview. One part is survival analysis background. Another part is survival analysis data. Survival analysis is a branch of statistics for analyzing the expected duration of time until one or more events happen. There are 3 kinds of methods for survival analysis: non-parametric distribution fitting, parametric regression modeling, and parametric distribution fitting. What's more, survival analysis method can be divided by whether it's modeling with the predictors. So the major method of survival analysis method are in following chart. We have different components to handle different requirements of survival analysis. For non-parametric survival analysis without predictors, we have non-parametric distribution fitting. We call it NPDF. For parametric survival analysis without predictors, we have parametric distribution fitting, we call it PDF. And for parametric survival analysis with predictors, we have parametric regression modeling, we call it PRM. The data type in survival analysis can be divided into 4 kinds. The first, I can show you failure data. Before this, I may introduce what is complete data. Complete data means that the value of each sample unit is observed or known. For example, if we had to compute the average test score for sample of 10 students, complete data would consist of the known score for each student. In the case of live data analysis, it's also called as failure data. Our data set would be composed of the time to failure of all units in sample. Please look at the picture. For example, if we tested 5 units and they all failed, we would then have completed information as to the time of each failure in the sample. All the 5 units data can be called failure data. Next, I will introduce the right sensor data. In fact, the most common case of censoring is what is referred to as right sensor data. In the cases of live data, these data sets are composed of units that did not fail. For example, if we tested 5 units and only 3 had failed by the end of the test, we would have right sensor data for the 2 units that did not fail. The term right sensor data implies that the event of interest is to the right of our data point. In other words, if the units were to keep on operating, the failure would occur at some time after our data point. What's interval sensor data? For example, if we are running a medicine test on 5 units and inspecting them every 100 hours, we only know that a unit failed or did not fail between inspections. If we inspected a certain unit at 100 hours and found it operating, and then perform another inspection at 200 hours to find that the unit is no longer operation. Then the only information we have is that the unit failed at some point in the interval between 100 and 200 hours. This type of sensor data is also called inspection data by someone. I can take you to understand what is lab sensor data. In lab sensor data, a failure time is only known to be before a certain time. You have known what is interval sensor data just now. I think it will be helpful for you to understand lab sensor data. The lab sensor data may have some similar points with interval sensor data. Lab sensor data is identical to interval sensor data whose starting time is 0. For instance, like the example I told you for interval sensor, we may know that a certain unit failed sometimes before 100 hours, but not actually when. In other words, it could have failed anytime between 0 and 100 hours. In some cases, the event of interest can happen on the observed subject several times, and that is what we call it recurrent data. Following table is a sample of recurrent data. One subject may contain multiple interval records, which represent the multiple observations of observed subjects, and each interval should have all the data fields that the survival analysis need, including the start time, end time, status, and so on. The difference of regular survival analysis data and recurrent data is that regular data only use one ID to identify one record, but in recurrent data, subject ID and interval ID are both necessary for identifying different records. For different subjects, the number of intervals are not restricted. Like the subject 1, there is only an interval in it, and for subject 10, there are 3 intervals in it. And also, each interval can have different start time and end time. But for the first interval in every subject, the beginning time should be 0, and the ending time of one interval should be the beginning time of the next interval. Now, let's start the part 2 of a non-parametric distribution fitting overview. For NPDF's inputs, we need survival time. It can just have one field for beginning time or 2 fields for beginning and end time. The status need to define in setting, and it can be categorical or continuous. But please pay attention. You must define all the values in status with a status type, like failure left sensor data, right sensor data, and interval sensor data. In other words, it needs to cover all status values in the defined status setting. NPDF supports recurrent data. For objectivities, we can compute the distribution of survival times, and we can carry out tests for group similarity and dissimilarity for each or across strata. PDF also supports left truncation time field. It can simply understand it, with the time is not recorded from 0. For example, when we interrogate a relationship between smoke and health, one smoker can just start to research from 12 years old because it's impossible for one start to smoke at birth. It's meaningless for the period from the 0 to 12. For the objectives, first we can get the parametric values for fitting distribution. It may be the most important part in PDF result. Second, it can judge if PDF has a good distribution result, the goodness of fit test. At last, it can also compare different groups' fitting results and give us a conclusion about similarity around each group. PRM can deal with the regular survival analysis data and the recurrent survival analysis data. For regular data, PRM can build a parametric eccentricity for the time. We call the AFT model. AFT model is a commonly used method for survival analysis, which assumes that the efforts of each single predictors AFT model consumes the regular sensor data, and the AFT model supports 4 survival time distributions, as per nation, variable, and log normal and log logist. PRM also supports feature selection to deal with the large number of predictors by leveraging ADMM with lasso method. ADMM is optimization framework for big data analysis. For scoring, PRM supports predict survival at regular intervals, predict survival at times specified by a variable, and calculating the hazard function. Here is a user case for NPDF. New drug weather can improve the traditional therapy and additive group of similar medications. We can help customer determine future actions. The time variable should be continuous. The status variable can be categorical or continuous, and the factor and the strata variable should be categorical if excited. Gender 0 is male, 1 is female. Health means 1 is poor, 2 fail, 3 means good. Treatment 0 is new drug, 1 is existing drug. Dosage 0 is low, 1 is high. Status 1 is censored, 2 means take action. The time at which the event of censoring occurred. Status indicates whether the case is present, the terminal events, or was censored. Factor select a factor variable to examine group difference. Strata select a strata variable which will produce separate analysis for each level of the variable. The plot for the exciting drug below that of a new drug throughout most of the trial, which suggests that the exciting drug may give faster relief than the new. The plot for the new drug below that the exciting drug throughout most of the trial, which suggests that the new drug may give faster relief than the old. Since the significance values of the test are all greater than 0.05, the composition test shows that there is not statistical significant difference between new drug and existing drug. Another user case for PDF and PRM. A telecommunications company is interested in the issue of how long their customers are more likely to train. The company wants to monitor the time to train in order to figure out How all the factors influence the time to train? In this case, behind the time to train issue, this telecommunications company want to answer the questions how to retain customers. For answering this question, we have to know the answer of following two questions. In the first place, for better understanding of the issue. The first one is, which kind of customers are more likely to train? And the second one is, when is the best time to take actions to retain customer? PDF and PRM modeling can help us to find these answers. Now, we can see the result. Because Mary does not know which type of distribution is most suitable for the customers. So she used all two distributions to fit. It will fit 4 different distributions for every customer group. She can actually see the basic server She can actually see the basic service group. The AIC value of longest distribution is the smallest one in distributions, and it means the longest distribution is the most proper distribution for basic service group. For the other customer group, they will select the most proper distribution by the sum method. After distribution select, Mary can get the survival curve for 4 different customer groups. Mary finds from the survival curve that 2 groups of customers train much faster than the other 2. Both the basic service and the total service loser more than 20% of its customers before reaching 20 months of service. So basic and total customers need more effort to retain after 20 method service. Mary predicts new customers would follow the same survival curve if no action is taken. At last, Mary also wants to know if there exists similar behavior around different groups. From the group composition result each other below. In the table, the significant value is showing and they are all less than 0.05. So the conclusion is that there exists no similar behavior around the 4 groups customers when the significant level is 0.05. It means there is no same actions can take for 2 different customers group. Mary need to make a different plan to retain customers for different groups. According to the distribution selected strategy, the similar value of AIC indicates the better distribution. So the longest is the best fitting distribution. In following table, 3 predictors are selected by feature selection, and that means these 3 predictors have very significant influence to the issue of time to train. These predictors are mental status, the categorical of customer, and the years with current employer. Survival plot is a very important PRM modeling output, which is in the stats.xml. The plot of survival curves for each correlate plotting gives a visual representation of the effort of customer categorical. Total service and basic service customers have lower survival curves, and they are more likely to have a shorter time train. The survival curve by multi-status curves show that the unmarried customers are more likely to have shorter times to train. You can see in the following chart the unmarried customers have a lower survival rate. After modeling, we can predict the time of user churn by scoring. Following table is the score result one customer record. You can see when the tenure is 12, the survival rate is 83%. And when the tenure goes to 72, the survival rate decreased to 35%. A downward trend can be seen very observably in the survival plot of the score result. Finally, I will show an example on SPSS. I have uploaded the data on the server before presentation, and I used two Scala scripts to call PRM algorithms. We can exactly see the setting and the data. Now we can see some data in the PSS, and I scripted some script in the DSX. First part, this function is used to set up across the Spark to your object storage. And this part, you can choose any time. Set circle context and define schema and export DF. Now we can see import the parametric regression package and define PRM, set begin field, set end field, set status field, and set predictor field. Define status. And we can cite the PRM, the feed, PML export, and stats XML export, and show the predictions. That is all my topic. That if you have an interesting program with using the survival analysis of SPSS, please free to contact me. Goodbye.